So what is that? Let's see here. We end up with like natural log of natural log of the absolute value of b minus the natural log of 2 plus the limit as a goes to 0 from the right of the natural log of 2 minus the natural log of a. No need for absolute values on that side because a is clearly positive in that limit. What's the limit of the natural log of b as b approaches 0? I mean, this absolute value of b is actually minus b, right? So we're looking at the natural log of a very small positive quantity. What is that? Mm-hmm. Which is? Mm-mm. Natural log of 1 is 0. Natural log of 0 is... It's undefined, yeah. Like this is minus infinity. This is infinity. But here's the thing. Those limits are separately diverging to plus and minus infinity. These don't cancel. They're not connected. You're like, well, don't they cancel? Right? Now, what's one other way you might have been tempted to define? Like, left to my own purposes, I probably wouldn't make this my definition. I would probably do the following. I would say this is the limit. Let's say t approaches 0 from the right of the integral from stink. Well, fine. Integral minus 2 to minus t dx over x plus the integral from t to 2 of dx over x. In other words, if I link the left and the right limits symmetrically, so if I say I'm approaching the left and the right at the same time, in the same fashion, then the infinities will cancel. Essentially for the crossed out calculations reason. You'll have like ln t minus ln of the other t, you'll get ln t minus ln t, those will cancel out, and you're just left with like natural log of 2 minus natural log of 2. You'll get 0 in this case. This is not, however, the standard definition for the improper integral. This is what's called the quote-unquote principal value. This is the so-called principal value of the integral. All right, it's the principal value of the integral, which is something different. We'll talk more about that in complex analysis if you take it. Okay, I'm just going to leave it at that. You might be Mathematica might tell you the principal value of an integral is such and such. The principal value of an integral can exist even though the integral itself does not. This is that example, for example, for such a case. All right, so there you go. I mean, these are just how we do improper integrals. So some standard examples for you. Let me introduce an application which I think is fun. Do you guys know about probability density? What are the sum of the probabilities? If you could buy all of the lottery tickets in a given lottery, what is the chance that, oh, this is not a good example. There really is, the way lotteries work these days, if no one's guessed the right number, nobody wins, right? So there is in fact not a probability 1 that someone's going to win a lottery, like Powerball at least. I need something that there's at least one winner. You and your friends are playing Trivial Pursuit. All right? No one plays that. I'm saying that. It's not a good example. You and your friends are playing some game, all right? All of your friends enjoy this game such that none of them will stop playing before the end of the game, right? It is guaranteed that the game will be played till its completion and someone will win. What's the probability somebody wins? Is 1, right? What's the probability you win? Well, it's something less than 1, right? If you're playing the game. The point is the sum of the probabilities is up to 1, is 1. Now, if you have something like a continuous probability distribution, what would that look like? So a probability density function is something like psi, or let's say, psi, a mapping from the reals to basically the numbers between 0 and 1, such that the integral from minus infinity to infinity of psi of x dx is equal to 1. So psi represents probability. So for example, the probability that you had something between a and b would be given to you by the integral from a to b of, psi of x dx. That would give you the probability. That would give you the probability that x was between a and b. All right. And then, of course, you can do different, there's all kinds of different probability density functions. Let's see here. How about you're picking a random number between 0 and 2. If it's random, if it's truly random, then your psi would look something like what? Like that. So the probability is 0 that you will pick a number outside 0 and 2. That's the parameters of the problem. What is the probability you pick a number between, say, 0 and 1? So what's this function? This is y is equal to 1/2. Right? So if I integrate from 0 to 1, psi of x dx, what do I get? I get 1/2, for example. What's the probability that you pick the number 1? That would be the integral from 1 to 1 of 1/2. The probability is 0 that you pick a specific number at random. Of course, the problem with this is people don't really pick numbers at random, right? The probability that a bunch of people picks the number 1 if they're asked to pick numbers between 0 and 2 is probably more like 90%, right? Because most people, when they hear between 0 and 2, aren't going to include 0 and 2. And the only number they know between 0 and 2 is 1, right? Talking about your typical Trump supporter here. Oh, I'm sorry. Hey, we're going to make math great again. Don't you worry. Let's see here. Whoa. I'll tell you this. If he does get elected, you won't see me speaking openly against the government. I don't want to go to jail. It's still recording? I don't care. Let's see here. I am, of course, speaking either as a comedian, a bad one, or as a private citizen, so, Or don't speak where you can be recorded, is that what you're saying? I'm sorry.
No, just mean like, you need to do it before you select one.
Oh, you're right. I'll have to take these videos down. Yeah, I know. Put me in the gulag, a la Putin. All right. So, popular question: find k for which psi of x is equal to k over 1 plus x squared is a probability distribution. An interesting probability distribution, for example, would be given by like e to the minus x squared, where you take a multiply by a constant. So here what you have to do, you have to integrate from minus infinity to infinity of k over 1 plus x squared dx. Now this is what? This by definition is the integral from like 0 to infinity of k over 1 plus x squared plus the integral from minus infinity to 0. Sorry, I did it in a weird order. Whatever order you like. And I'm out of time, so I'll stop. But you keep going with this, and if you set this equal to 1, it will force you to choose k as a specific value in order to scale the area. I mean, what does this graph look like? 1 over 1 plus x squared is something like this, right? And so a specific choice of k will put the area under this infinite graph to be 1. Okay. Anyway, I will stop talking because it's time. So. Tomorrow we likely have a quiz on L'Hopital and sequences.